Yo guys, welcome back to the series. On this part of the series, what we're going to be doing is making the keyboard work so that you could type stuff on the GUI. And the reason we're doing that is because we're going to actually make it so you could write stuff in the console tab that we made right about here. But before we do that, I just have a few things I want to change. Let's go to Kernel.cs, and I made this really simple logic right here, but we can simplify it. I mean, like, it doesn't have to be 4 lines, so let's see here. Yeah, this could be 1 line, so just console.writeLine, and then there's no need for that variable. Can eliminate that, and we can eliminate the input variable. And basically, all I did is I took the things that the variables were being set to, and then I just moved them into wherever they whatever they were going to originally do. So now it's 1 line, and that should still work fine. I mean, I'll run it to make sure it does, but like, it will. If it doesn't, then you can laugh at me all you want, but like, it's gonna work. And I have one more optimization I want to make, and I was just looking at the font.cs, and I realized that we actually don't need to keep track of where we don't want to draw anything. So, for example, we don't want to store these zeros in our list here, because we don't draw here. Like, we don't need that information, because we just completely ignore the zeros. The 1 is where we actually draw. So what we can do is just completely get rid of this boolean, and get rid of the boolean for all of these tuples, and instead of writing into the tuple whether or not we draw, what we'll do is only store the data if we can draw it. So just move this out there to right there. And another thing is we don't need this. I'm just gonna move this all into one line. And I believe that's gonna be the extent of our modifications for this. Yeah, it is. There's nothing else we could really optimize. I was looking at this, and there are a few things we could optimize, but we'd have to optimize it here, and I don't want to make this more than 1 line. So if it ever becomes a really big problem, I mean, it's always better to optimize, but I'm not trying to make this more confusing since it's a tutorial video, and we'll just go bit by bit. But yeah, we'll just check if the console works right here. Still works just as it normally would. And yeah, so those are, as far as the tweaks go, those are all the tweaks that we're really making. But as I said, in the console tab, that we're gonna actually make the console work today. So in your console window, command prompt window, you'll see that you're able to type somewhere, and then you also have a line where you get a response. So we'll just create a few components that will let us display the response and input on the screen. So as you can see, whenever we want to draw something on the screen, we create a new text class. And I know I probably should have named it text component. It's a little bit misleading, but I trust that you guys know what it is. It's a component. So we're gonna create 2 of the components. One for input, and the input is just gonna be where you write, and the response as well, so where we get the response. And for the input, we're gonna put it on the most bottom part of the console, so that we have space to write as many responses as we want, or whatever we need to, or that, and also so that it's very obviously separated. So for the X, we're gonna set it to the leftmost part of the screen, because it wouldn't make sense to set it halfway in the screen or something, unless it was being centered, and that's a little bit too advanced for us. So I'm gonna set this to 0, and then for Y, as I said, it's gonna want to go at the bottommost part of the screen. So what we actually have to do here is take the default window size, which is 400, that's the height of the window, and subtract it by the top part of the window, because we need to account for this up here, that part of the window, and then if I just set it to this, what it will do is it'll just start drawing directly on, it will draw directly under the console window, or they will draw directly under the window. So what we have to do is account for the actual height of the character as well, and what we do is we say plus this dot console text font dot BPL, and as you guys know, BPL is both the height and the width of the characters. And then also, if I do that, then it will draw directly on the bottom of the window, but we want a little bit of space, so we're just gonna add +1, so that there's 1 pixel of space. And then we'll go ahead and set the default thing just as an underscore, so that the user gets the they get the idea that they're supposed to type, because in the command prompt there's a flashing underscore. We're kind of doing something like that. You could look at it as that. And then yeah, the next 2 variables are the fonts and pens, and we have it stored up here, so we could just easily put those variables there. For the response text, we want it to be on the 3rd line, and I realized that it might not be obvious how I got the 17 to put it on the 2nd line. Basically what you do is you go ahead and take your the height of your font, which is the BPL, and then you add 1, because you want them to have 1 pixel space in between each line, and that's the reason that there's 1 there. And then what you need to do is multiply it by however many lines you want it to skip. So 2 lines I want it to skip, and that's done. And now we have the text which is set to blank for now because we have no response yet. And then we just want the font and the pen. Now what we have to do is keep track of what the user is inputting into the console, and we can't keep track of it on the input text control, because as you see, for example, there's many reasons, but one reason is that we have an underscore here, and that's not what the user actually put in his input, so we gotta keep track of it ourselves, and so that it's more direct, and we don't have to rely on the other class to keep track of it for us. And since we're going to be constantly appending it for every character the user types in, we're going to make it a string builder, because as I said earlier, if you want to continuously append characters or strings to a string, you need to make a string builder. And then we're gonna right here just give it a constructor. Next thing we're gonna do is go to our GUI tab, GUI.cs, and here's where we're actually gonna get the keyboard input. And as you guys know, the first place where we directly handle every single input is in this function, handle GUI inputs. So what we're gonna do is go above all the mouse handling we did, and we're gonna import, and we're gonna first write down a key event. Now we're gonna call it key data, and you can't see this on my screen, but if you go ahead on your screen and type key data dot, you'll see how many useful things there are. You can get the key character, you can convert it to a string, you could get the type, you can do all that kind of stuff. And that's why we're calling it key data. It has all the data for the key that's going to be pressed. But now we actually have to do two things. We have to check if the user pressed a key actually, and if he did, we have to get the key data. And luckily we can do this all in one line. So first, try to read the key, and this is going to return true if the user did read a key, and return false if they didn't. And now you might be wondering, okay, well, if that's the return value, how are we going to get the actual key data? Well, all you have to do is simply type out key data, and then it's going to put the key data out into the key data variable we have. So if the user did read a key, type a key, then we're going to have to process the key press. And the way we do that is we have to go into the tab class we made, and it's the exact same thing we did with processing left mouse button down and release, except this time it's going to be for key presses, and we're going to make it so that you can read key presses on every single tab. So what we'll do, make a virtual void on key press, and then it's going to take for an argument the key data. But now we actually have to call that function. So we're going to go ahead and try to process key press. Similar to how we tried to process left mouse button down. Or we're not even trying to, we know that there's a key press, so what we have to write is just process key press. And the first thing we're going to do is check if there's any tabs open. If there's not, then what's the point of doing anything, so just don't do anything. And now, just like the processing left mouse button down, we leap through every single tab. And then we tell them that there was a key press, and we call this function. And then we have to pass in the key data, so simply pass it through. However, there is an issue with this, and I'm proud of you if you figured it out immediately. But what this will do is make it so that whenever you type a key, it's going to tell every single tab on the screen that you typed a key. And obviously on Windows, if I type something on here, it's not also typing on here. It's only typing on whichever tab I have focused. So what I have to do is create a new variable, and the variable I'm going to create is called public boolean focused, and we're going to have get so that anyone can check if the tab is focused, but only we could set if it's focused, and there's a reason for that. the next thing we're going to have to do is go into the constructor here, and we're going to say, if this is the first tab being opened, so if there are no other tabs, that's how we check that, then set it to the focus tab, because if it's the first tab the user's opening, they probably automatically want it to be focused. And if it's not, then they might not want it to be focused. You don't really know, so we'll just be safe and set it to false, and they could just click on it themselves. And now as I just said, in order for the user to focus on a tab, they're gonna have to click on it, but we haven't written the code for that. So the first thing you do is go to the function that processes whenever you click. So this is where your left mouse button goes down, and we're going to go behind all of these if statements, and we're going to just check these if statements. Check if you clicked on the top part of the tab or the X button. We just want to check if you clicked on the tab anywhere, including the top part, including the X button, because then it'll all be focused. And if you do click on the X button, then yes, it will close the tab, so it's kind of pointless, but still. So simply check if the mouse location is on anywhere on the tab. Get the tab's location, and then the size of the tab. And yeah, that's something that I don't even think we've done yet, getting the entire 400 by 400 part of the tab. And then what we're going to do is, we haven't created a focus function yet, but I'm going to write it right there. And the reason that we have to make a focus function instead of just doing focused equals true is because if we do that, then that means multiple tabs can be focused at once, which is not good. That's the reason that we have to make this have a private set in the first place, because we don't want other people to make it so that multiple tabs are focused at once. And the way that you solve for that is pretty easy. We'll just go up here, because this is everything we've made today. Go through every single tab. Check if it's the focus tab. And if it is, then, well, unfocus it. And now looking at this, since there's only one tab that can be focused, what we can do is, once we find the focus tab and we unfocus it, we can just stop this loop entirely, because we've already found the focus tab. We don't have to search for any more tabs, because the whole idea is you can only have one tab focused at once. And then the actual thing we have to do is set that R tab to being the one that is focused. And now the error that was originally right here is gone. And the reason that we're not doing an else if here is because even if you are clicking anywhere on the tab and you focus it, we still want to check these things. And now the last thing we have to do is check it in here if the tab is focused, because we only want to write to the tab that's focused. Now we go back to our GUI and we can finally fill this in. Alright, that looks good to me. And well, now what we could do is go back to our console tab. And in our console tab, since we made a virtual void here, if you remember, maybe you don't remember, but in a previous video I said that if you make a virtual void, that means that you could override it. So basically, whenever this tab has a key press, we don't want it to do nothing, because right now it does nothing. Every single tab automatically does nothing because we wrote nothing here. We want to override that and make it actually do something. It's gonna fill it in, and it's gonna, when it automatically fills it in for me, it's gonna say, well, first do this, because that's generally the good practice to do that. But as you can see, it does nothing, so there's no point of having that, so we just get rid of it. And now what we could do is simply we could check what the user input. So if they input, for instance, the key enter, that means they want to submit their execute their command. But that also means that the input gets cleared, because whenever you press enter, obviously it gets rid of your input. See, I'm pressing enter and it got rid of my input. Now I have nothing in there, so we have to clear it. And now we're going to set it back to being an underscore in the input text, as we did right here, for the same reason, just because we want there to be some kind of indicator that we expect them to type in something, and then we actually want to draw the text. We want to draw it so that it updates that it's empty. But in the case that they put a backspace down, what we do is we redact the key. And the way we do that is we say this.input, and there's unfortunately no redact in here. You can't remove the last thing directly, but what we can do is do this.input.remove, or this.input equals this.input.remove, and then for the start character you want it to be the last one, so we're gonna get the length of the index and reduce it by 1 because it's 0 based, and the length isn't 0 based. And then for how many characters we want to remove, we just put 1. So what we're doing, selecting the last character and removing only that. Then we're going to take the input text. This is a little bit misleading and confusing, I know, but the input text is just the component, and the input is the actual string builder. And we're going to set the input text to the new input with the removed last character, and then draw it so that it can update. So that it can update the backspace character on the screen. And now, in the case that it's not enter, it's not backspace, that means the user actually wants to type something. Unless there's something that I missed, which if I did, doesn't matter, because it's not that important, because this is all you need really to type in commands. So this.text, or this.input.append, as you guys know, to add a character to string builder, all we do is .append, and then we're just gonna get the key character. Then set the input text to the new input with the added character, and then draw it, and that's it. Apart from the fact that later in the video we're gonna actually make it execute a command. But the thing is, we never actually accounted for backspacing. So what it's gonna do is it's not gonna get rid of the last character. It's gonna draw over it. And I'll actually show it right now. I believe this should work. Okay, so that we did have an error. I'm gonna double click it, and it's gonna take us to the text component. All that we have to do here, get rid of this boolean, get rid of this line, because now we don't have to check that. And I'm just gonna wait for this to run here, so because this isn't gonna work entirely, there's gonna be one issue, and in order for me to explain it, I have to just show you. I think I forgot something, to be honest. Let me go back to my console tab. Yeah, I did. This.add components. This.input text. This.add component. This.response text. I didn't actually add the components, but I think that even though I didn't do that, it'll still draw if I try to move the tab because I wrote that. Or if I try to press, I mean. That's unexpected, but yeah, you can now at least see that it is drawing. And although off the screen, I'm able to type in any character I want. I'm just typing in random right now. I'm just seeing if it's ever gonna stop drawing, cause it. No, it's not. Well, now what's gonna happen if we try to backspace? Well, I'm gonna backspace twice, and let's see what happens. As you can see, it drew an A right here, because it didn't actually get rid of these last two characters. And I actually need to figure out why that it's going off the screen for a second. Let me take a look at the code. I mean, I think that now that I put this down, it might work. I'll run it to make sure. If not, I'll try to figure out what happened wrong. But anyway, now to fix that, that backspacing doesn't actually get rid of the character. What we actually have to do is it's gonna be laggy. Not really laggy, but pretty laggy. And what we have to do is save all of the pixels that we have to redraw this every single time. So we basically have to clear the text and then redraw it. And the way we do that is we go up here, and we've done this time and time again, but let me just make a quick import here. Sys equals cosmos.system. And we've done this time and time again, but we need to get point, color, system.drawing. Pixel data. And we've done it time and time again. We have to save the pixels. We did this with the mouse. We did this with tabs. It's going to be a common trend among making your own operating system. You have to continuously save the pixels and redraw them. And now we actually have to initialize this in the constructor here. Right here there's going to be an error because I imported system.drawing. Just going to fix it by doing that. And actually what we have to do is open this up anyway for later. So I'll do that. But up here, what we're gonna do before we do anything, what we have to do is save the pixels, or I mean restore the old pixels. So we're gonna go through every single pixel in this list, and if it's empty, it's not gonna matter. It's just not gonna loop through anything, so you don't have to worry about that. But before I continue that, I'm just gonna check where we're at with this. It'd be really a lot easier to... Okay, it still makes it right there. I'll figure out why momentarily. Yo guys, I'm back. Sorry about that, but basically I figured out what the issue was, and it was just a typo. So if we look right about here, as you can see, we're on the x-axis because we're on the first argument for point. But instead of adding the x, we added y. So that's kind of awkward, but all you gotta do is just change that, and I'm gonna run this and see if that fixes it, which it should. But anyway, where was I? Right, so basically what we're doing is, since the backspacing doesn't actually get rid of the character on the screen, what it does is it only gets rid of it in this string builder input. So what we have to do is go through every single one we gotta save the pixels, the same thing that we did with the mouse, and when we were saving the pixels behind the tab, we have to save every single pixel that we draw here. But although we haven't saved them yet, what we're gonna do is restore them first, because before we actually draw them here, because this is where we actually draw them, we have to restore them. And the way that we restore them is we go through every single tuple in this.pixel data, and basically, I know that this is empty right now, but we're gonna fill it up, like, I'll explain later, but we're gonna fill it up later. But for now, we're gonna pretend that this is full of pixels that we need to replace with their original values. So what we do is, I'm sure that a lot of you guys know how to draw pixels by now. All you gotta do, kernel.gui.canvas.drawpoint. And, you know, this is probably gonna look familiar, and as I said, it is familiar because we've literally done this probably 5 times now. If you don't remember, go back to your, like, tab, go back to tab, and then as you can see, we did literally the exact same thing right here. And for the exact same reason. The only difference is apart from the variable name is different, we're saving not the tab pixels, but the pixels behind the text. And there you go, it's fixed. So what I was trying to show earlier, I could probably show it better now, is I've just typed in like a random string. And if I backspace, I haven't typed anything from where I've left it right now. If I watch carefully, I'm gonna backspace 3 times. And nothing happened, but right, you might think that nothing happened, but if I type A, B, C, as you can see, it left off where I should have backspaced at, but it didn't actually get rid of these characters. So all we're doing right now is, now we have to restore those. We have to redraw the entire text. We have to redraw everything, and that's how we fix that. So we've restored the pixels here, except we haven't stored any pixels in the first place. So the way we do it is we go through every pixel we're going to modify, and this is really good and efficient because this loop only goes through pixels that we want to modify. And we're going to save it just by adding it to the pixel data. And since we don't want to make this point twice, all we want to do is copy it. I put it right there. It's going to get auto-formatted, which is really weird. Now it's going to be kind of harder to read everything, but fix that really quick, not big of a deal. And now for the first argument, which is a point, we could simply do that. And then down here, the second argument is a point, we could just do that. And that just makes it a lot simpler. I guess I have to... Oh. It's yelling at me because I haven't finished this. But for the second argument here, we have to get the color. And as you know, the way we get a color of a pixel, kernel.gui.canvas.get point color. And then we can't actually put a point in for this, so we'll just do get the X and the Y's. Still makes it easier for us, really. And then we're going to need one more bracket right there. I'll run this. Hopefully that it's fine. I'll look through it right now. So basically what's happening here, this is where we draw the pixels. We did this in a previous episode. But before we actually draw the pixel right here, what we have to do is save it. Save the original pixel so we know what color was behind it. And then when we redraw it, it will restore the pixel that was behind the pixel that we modified. And now we just wait patiently for it to run. Alright, now this is opening. You'll notice that the console opens, and let's type a command. You can now see that it is redrawing itself every time I write, and this doesn't have much performance issue, but the more I type, the laggier it is. And now I'll just try to backspace, see what happens, and it successfully backspaces. I accidentally pressed equals, but if I press enter, it gets rid of everything. Everything. Backspace that. And now we come to the conclusion that that works fine. Now the final thing that we have to do is go to our console tab. And we actually have to make it run commands. So, this is where we make it run commands. But what we're going to have to do is create an instance of our command manager. Because as you remember, this is how we actually process the commands. So, up here, I'm not sure why I made these public actually. These should be private. And under that, private, and then you write down command manager. Or first we have to import it using type the name of your namespace .commands command manager CM or whatever you want to call it, and then in our constructor where we initialize everything else, this .cm equals new command manager. Now what we do is we say cm.processInput this.input.toString, because this.input is where we store the text that the user wrote down. And finally, we have to write the response. So what we do is we say the response thing is right here. That's what we called it, response text. And we set the text value of our component, our label basically, to the return value of process input, which is the response. And then we just have to redraw it. Run this. I'll edit this out as well so it gets ahead. Alright, so our operating system launched up. Open up the console, and we'll see what happens when we try to run some commands in. And it doesn't fit the whole thing, but as you can see, it says welcome to practice OS, help command, etc. Let's see what happens if I try to launch GUI. You are already in GUI. What else is there? We'll try to make some files. So, you know, those commands are kind of useless, but like, let's see what happens if I try to make some files. Oh shoot, I really hope this fits. I'm doing this slowly. I just realized that I don't think I'm gonna be able to shift things in, but like, I'll try. Oh, I can. Okay, never mind. And, the final thing that we have to do is put the file name, test. We don't really have to put it .txt, but I will. Okay, I wrote all of it. Your file was successfully created. That's what it says. And we could make this go into 2 lines. The only reason I have it is because this video is pretty long already. And I already have, I don't really edit my videos, but I'm gonna edit this one. Because, I got a little bit of things to cut out, like to save time and stuff, and because I had to fix one error. Now let's just try to delete the file. Alright, I wrote everything. This is how fast it goes but on its own. It's really, there's the long commands that are going to take the longest to actually run. But your file was successfully deleted. And I know that it's pretty shitty as far as like, appearance. It doesn't even tell you the whole command. But the point of this is that so it's functional. In the next video, I'm depending on what I do, I don't really have a plan. I might fix that, make it so that it's multiple lines. I might have to make a new thing called multi-line text, a new component. That might be something I do, but for now, we're just gonna leave it at this because this video has been going on pretty long. So I'll see you guys in the next video.